Okay, we learned how to solve the system of linear equations with two variables. Now we're going to do the next one, that is a system of linear equation in three variables. Okay. In order to solve this, the system or systems, because if we want to solve more, the system of the linear equation of 3, that looks like this. That looks like some x, some y, some z equals a number, and some x, some y, some z equals a number, things like that. So let me give you just a look. X plus 2y minus 3z equals 9, and 2x minus y plus 2z equals negative 8, and then negative x plus 3y minus 4z is 15. This is a very typical system of linear equations in three variables, x, y, z. Your job is to find x and y and a z. You find that solution. So you find the value for the x, y, z, and you bring back to each of these three equations. They're all equal. How should we do that? We already learned how to do that in two variables. If you have just two variables, then we already did graphing method. Of course, I don't like that because I cannot graph very well. And we use the substitution method if we find there is one variable has the coefficient of 1, and then we can do that. And then the last one is the elimination method. If we use one equation multiplied by a constant, by a number, and then that I make the coefficient of that for one variable, it just has the opposite sign in the other equation, then I just add these two equations up, then we can eliminate the method. Now, the way to do this 3, this is the equation 1, this is the equation 2, this is the equation 3. We have 3 equations with the 3 variables. The general idea is to use elimination method. What we're doing is, think about this. We have three equations. We can put them in 3 pairs, 1 with 2, 1 with 3, or 2 with 3. What I would ask you is this: pick 2 pairs out of these 3. It cannot be repeat, and you don't need to pick all of them. So pick 2 pairs from these 3 equations and eliminate the same variable. Once you starting from a pair of equation, you eliminate one variable, you get an equation with the 2 variables, right? And then you choose another pair. Think, you're going to eliminate the same variable just like you just eliminated earlier. So you're going to have another equation with the 2 variable. Okay, now from these 2 pairs, you get 2 equations with 2 variables. So you kind of reduce this into system of linear equations in 2 variables, and then you know how to do it. You get the idea? Okay, so now we pay attention, we check 1, 2, 3. For all the questions look like this. There's no fixed method. There's really no say you have to do this, you have to do that. However, you can choose whatever method you like. You can eliminate whatever method, eliminate whatever variable. However, no matter what you do, at the end, you should have exactly the same solution. And the good thing, like I told you earlier about solving the system of linear equations, is once you have the solution x, y, z, you can always plug it back into all those 3 equations to check whether they are actually the answer. Okay, so I'm going to try to do this one, and I look at here. The coefficient of x here is 1, here's a 2, here's a negative 1. So that makes me think, if I add the first and the third, if I add these 2, so my x will be gone, isn't it? Yes, x will be gone. And if I multiply this by 2, multiply this equation by 2, and here becomes a negative 2x. If I add 2, the equation 2, then x will be gone too. So this and this pair and this pair are going to be the pair I choose. Okay, I like to label those equations with some numbers just for me, okay, so I can remember. Now I will add the first and the third. So I will write here. So x plus 2y minus 3z equals 9. That's my first. And the third one is negative x plus 3y minus 4z equals 15. That's my number 3, right? And if I add them up, the x will be gone. So I will have 5y minus 7z equals 24. Let me call this as number 4. You just keep labeling them. It doesn't really matter you choose this as a number 1 or number 2, doesn't matter. All right, now the next one, the next pair, I'm going to choose this too. If I use this equation number 3, if I use this multiplied by 2, what do I have? I have a negative 2x multiplied by 2, okay, plus 6y minus 8z equals 30. Okay, I can call this as number 5. It doesn't matter. You can call this number 10. And then I am going to add to the number 2. Let me just copy that. 2x minus y plus 2z equals negative 8. That's my number 2, right? And then when I add them up, what do I have? X will be gone. And here is 5y. And here is minus 6z equals 22. That is my number 6. All right, now see, I choose this pair 1 and 3 to get this equation with the variable y and a z. And I choose the pair 3 and 2. I did a little bit of thing, and then I eliminate the x. I get another equation with a y and a z. So I have this we have these two equations we put in the system. So I have y minus 7z equals 24, and I have a 5y minus 6z equals 22. Okay, I notice that here's a 5, here's a 5, so I can use either one. This is my number 4, and this is my number 6. So let me do this. Let me use number 4 multiplied by negative 1. So 4 times negative 1. That's for me, okay? I just try to remember what I did. So that will be negative 5y plus 7z equals negative 24. Let me call this as number 7. Okay, and then this is 6. I just copied that. 5y minus 6z is 22. That's a 6, right? Okay, next I'm going to add this 2. So negative 5y and 5y will be gone, and this is z equals negative 2. Bingo, I got a z. Now, think about that. You're starting from 3 variables. You kind of eliminate 1 variable, you get a 2 variable, and then you use the elimination method again, you get the solution for 1 variable. So once you have z, you can plug back into either 4 or 6 to solve for y. So let's do that. Let's put in 4. So I got a 5y minus 7, and the z is negative 2, and that is 24. Okay, so which means 5y plus 14 equals 24. I subtract 14, so I get a 5y equals 10. Do I get a y? Y equals 2. Once you have a y and a z, you can bring back to any of the first 3 equations. Let's put in first. So we have y equals 2, z equals negative 2. Let me just copy that. X plus 2y minus 3z equals 9. That's my first equation, okay, because my paper is too long, so that's why I copied this for you. And I'm looking for x, so x plus 2y, and I already know y is 2, minus 3z, and I know z is negative 2, equals 9. All right, so that is x plus 4 plus 6 equals 9. That's x plus 10, so I subtracted 10, so I get x equals negative 1. Okay, so you see you have x, you have y, you have z. Therefore, your solution is this: negative 1, 2, negative 2. That's the way you show your solution. Or you can just write x equals -1, y equals 2, and then z equals -3. What do you think? It's just tedious. All right. So I want to use the same equation. I want to go with the same equation, but this time I do a little bit of extra. I just need to eliminate y, because here is a negative y. If I multiply by 2, I get a negative 2y. I can add to that. If I multiply by 3, I get a negative 3y. Then I can add to this one. Do you see that? So what I'm going to do is I will keep the first one, which is x plus 2y minus 3z equals 9. And then I'm going to use the second one multiplied by 2. Okay. The reason I want to do that is later I want to eliminate this y. So the second equation multiplied by 2, I get a 4x minus 2y plus 4z equals negative 16. And then I can add. That's the purpose, right? That's the purpose. I multiply by 2. So I get a 5x plus z equals negative 7. All right? And then I do the next. I go this guy, this second equation, I multiply by 3, then I add to that. So the second equation we multiply by 3. That will be 6x minus 3y plus 6z multiplied by 3, 24. Okay, and then I copy the number 3. That is negative x plus 3y minus 4z. I just copy it, equals 15. I add them up. Y will be gone. I get a 5x plus 2z equals negative 9. See, again, I get this two equation. This one and this one. They are the equation with only x and a z. Again, I see that here's a 5x, here's a 5x. I can just use this equation multiplied by -1 and then add to it. Or, did you see here, the z? You can use a substitution method. You can get a z equals negative 5x minus 7, substitute to here. Then you're going to have an equation with x and solve it, and then go ahead and do it. So I will stop here. Basically what I'm saying is you have definitely more than one method or one way to solve it. And then once you solve your solution, once you have your answer, -1, 2, 2, if you're not 100% sure that you get it right, you can always bring it back. Okay, I just put in here -1, 2, and a -2. If you plug in x equals -1, -1, and then here 2 by 2 is 4, so -1 positive 4 is positive 3. And then -2 here, so times -3, that's a 6. 3 plus 6 is 9. Yes, and then you can go ahead and put into the other two variables. So that's a general idea to solve this equation with 3 variables. Now next I'm going to tell you one application, how to use it. Okay, for a quadratic equation function. Okay. Now for linear function, if I give you 2 points on the linear graph, then you can find the equation. I tell you what, for quadratic function, if I give you 3 points that this graph, this quadratic function passes through those 3 points, then that function is fixed. The function looks like this, right? ax squared plus bx plus c. That's f of x equal, isn't it? Which means if I give you 3 pairs of x, y, you plug in x and y, plug in x and y, plug in the third points x and y, you get 3 equations. And that's the system of equation in 3 variables. What are the 3 variables in this case? A, B, C. You go ahead and solve for that, and once you find A, B, C, you find the quadratic function. Okay, so let me tell you this. It passes through, I give you the point, 0, 5, okay, and 1, 6, and 2, 11. Can you identify this quadratic function for me if this quadratic function's graph passes through this 3 points. So this one 0, 5, which means when x equals 0, y equals 5. That's y. So therefore 5 equals a times x equals 0 plus b times 0 plus c. When x equals 1, y is 6. So 6 equals a times 1 squared plus b times 1 plus c. And then when x equals 2, y is 11 equals ax squared, which is a times 2 squared plus bx, b times 2 plus c. Those are the 3 equations. Of course, it looks pretty ugly, so I'm going to rewrite that. Ax, oh well, this is a 0, this is 0, so I already got a c right away. So I have a c equals 5. And here, 1 squared is 1, b times 1 is just b. So I have a plus b plus c equals 6. So this comes from this. And this one is a 4. So I get a 4a plus 2b plus c equals 11. Those are my pretty looking system of equations. So once I have c equals 5, I can just put in here, and then so when here is a 5, I get an a plus b plus 5 equals 6. So a plus b should be 1, right? I subtracted 5 each side. And this one, I got a 4a plus 2b equals what? Here's a 5. I subtracted 5 on both sides, so I get a 6. But did you notice that this all the coefficients are divisible by 2? So I have a plus b equals 1, and here I divided by 2 everywhere. I get a 2a plus b equals 3. Okay, so this, and then I'm going to use either substitution method or elimination method, because here's a b, here's b. I just use this, multiply by -1. So I get a negative a, negative b, which is -1, and then 2a plus b, which is 3. And then I add them up. I get an a equals 2. And a plus b is 1. When a is 2, my b has to be -1, right? 2 plus -1. And then so I got an a, I got a b, and I already have c. Now, can you tell me what that quadratic function is? That f of x, remember, is ax squared, so that would be 2x squared plus bx, which is minus 1x, and then plus 5. That's my answer. Okay? Yeah. Now you probably think, if you followed me, then it's pretty easy to follow and to see what I'm doing. Otherwise, I still like you to put the number for the equation and take a little note. What did you do? For example, this equation is number 8. Then here you're going to put the equation number 8 multiplied by -1, and then you get the equation number 9. Things like this, that will help you a little bit, so you can remember what did you do. That will help you also when you go back to check your answer. And this one is also, you can check your answer to see whether when your x equals 0, 0, 0, is your y 5? Yes. When x equals 1, so 2 minus 1 plus 5, is that 6? Yes. When x equals 2, so 2 squared is 4, 2 by 4 is 8, 8 minus 2 is 6, plus 5 is 11. So you get that right. Okay, so we learned now the system of equations in 3 variables, and we learned one interesting application of it is to identify the quadratic function given this graph of the function passes through 3 points. Okay.